Welcome. Hi. So, today I'm going to start with a little story before we get into it. So, a long time ago, before I was a programmer, I was a temp at a Norwegian cell phone company in customer services. So, I answered the phone. One thing that's funny about customer services is generally people are always in a bad mood when they call you. There's a reason why they're calling you, they're not happy. But I was a really bad customer service representative, or at least exact if you go for how you measured good in this industry. Basically, we were measured by how many calls can you take, how fast can you finish a call, and did you manage to sell something. I was bad in all three categories. I generally didn't take that many calls because I spent a lot of time on my calls and I never really sold anything. And the reason why I did that is, and I guess it gave an idea on who I was going to be in the future. But basically, I was there to try to solve problems for people. And what you often saw is that most of the people working in customer services having these measurements, right? They wanted to get off the call really fast. So if they couldn't fix your problem quickly, they said they would call you back. They didn't call you back. So by the time they got to me, these people had been told they would be called back many times. By the time they got to me, they weren't just normally annoyed, they were really angry. But I guess it has to do with my character. I was like, I was going to solve this problem for them. And generally, they weren't easy problems because if they were easy, the other people would have done them. So I ended up with having like really weird problems that were difficult to solve. Which brings us to so that kind of sets the stage. I was used to solving difficult stuff. I was used to having to debug and go and to look through logs and all sorts of things to try to figure out what had gone wrong. So generally I was used to solving difficult problems. And I was really good at this. So people would actually call and ask for me because they knew, okay, she's the one that actually calls people back. But anyway, so one day I got a call from this guy, and he goes, "Okay, so I have this problem. I can't get any incoming calls." And I'm like, "Okay, so you can't get any incoming calls? That is weird." Okay. And so I was like, "Okay, so let me see." So I go through all of my systems. I can't find anything wrong. And I go like, "Okay, so I'm gonna have to call you back." That's usually when they freak out, right? Start yelling at me that, no, you're not going to call me back. And this guy was no different. And I was like, no, really, okay, here's my name. If I don't call you back, you can call me. You can, because usually they don't want to give their names because no, they don't want anybody to know that they don't call anybody back, right? So I was like, here's my, not only my first name, my second name, you can ask for me by name if I don't call you back. That usually goes like, they'll begrudgingly accept it, but they still don't believe I'm going to call them back. But anyway, so then I go down, I talk to the techs, we go through the logs, try to figure out if anything is wrong with this guy's subscription. Why can't he receive any calls? And I can't find anything wrong. Everything looks fine everywhere. So I go back, I call him up on the phone, and I go like, okay, seriously, I can't see anything wrong with your subscription. Okay, so what I'm going to do is I'm going to call your phone and then I'm going to see. Maybe I get some kind of error signal or something, some idea on what is going on. So I call this guy's number and it rings a couple of times and he picks up. And I'm like, hello? And I was like, but you said you couldn't get any incoming calls. And he was like, no. Yeah, I can get incoming calls when my phone is on. Because this is where you learn to be professional. It's like, oh my God, I cannot laugh right now. And I was like, okay, so when your phone is on, you can get, yeah, but when I turn it off, I can't get any calls. And I was like, okay, so this is sort of like your stereo. You know, when you turn it off, you can't play music. That's sort of how cell phones work. So if you want to get calls, you have to turn it on. And it's like, hang up and then you laugh afterwards. But the point of the story is that I was missing the obvious, right? Most times when you call customer services, they go like, okay, are you sure it's plugged in? But I was not used to asking those questions because all of the easy questions were always handled by somebody else. By the time I got stuff, it was all of the simple stuff was gone. I only got hard things. And in this case, it wasn't easy. It was the easy thing, but it didn't occur to me to ask. So today we're going to talk about DevOps, squeezing some kind of sec in there. And this is me. So I've worked on browsers, embedded systems, and also some on Java with like the normal backend, front end kind of thing. So I've mostly been working in C++ my career, but also with my second language being Java, and lots of like other things like JavaScript, Python, things like that. Mostly working on Linux throughout my career. Okay, so why would you even do this, right? It's like people come like, oh, DevSecOps is really cool. Why should you do this? So this is from Accelerate, an absolutely fabulous book, and you should read it. But I'll read the quote. This book actually is the scientific basis of a lot of the state of DevOps reports that come out every year, which has a lot of the science evaluating DevOps. So this quote is from her book. There are a bunch, but the main author is a woman. Our research shows that building security into software development not only improves delivery performance, but also improves security quality. Organizations with high delivery performance spend significantly less time remediating security issues. So basically, you might think that, okay, DevOps is really bad, but actually it improves security. When they measure it across organizations, security quality metrics actually improve when you go over to DevOps practices, which is kind of weird, but it is largely supported in scientific literature. But I've been researching this for a while, and I get annoyed. I get annoyed about these kinds of diagrams. I think very often you shouldn't have any diagrams. The diagrams can confuse the issue, can make things seem easy that are not easy. Because this looks like the whole process is about having some kind of release pipeline, then some kind of feedback loop, and all of these things, and it sounds really easy, but it's not. Well, technically it's doable, right? But what you see in organization after organization is that what really trips you off is like people stuff. So you have other types of drawings where, I made some circles and now it looks like I missed half of the Olympics. Or then you could do this, just to like have an extra loop to make security feel looped in to the whole loopy thing. But actually, I think all of these are bad. And they're bad because they miss a lot of the nuance on how these functions are different and why that often causes friction. So I have another quote about looking for zebras. This is a quote from House, the TV show. And it's Dr. Lisa Sanders who says this. She says, in medical school, you are taught that if, metaphorically, there is the sound of hoofbeats pounding towards you, then it's sensible to assume they come from horses and not zebras. With House, it's the opposite. We are looking for zebras. And that is because House also had a little bit like me at customer services. You got used to a certain class of problems. With House, all of the normal stuff is already been covered by other doctors. By the time a patient appears on his doorstep, they've been through dozens of other doctors. All of the obvious stuff is gone. The only reason they turn up there is because nobody else can figure it out. So for normal doctors, they always see horses because that's 99% of all their patients will be normal problems. But with House, it's the opposite. They're always like weird things, like 1 in a million kind of things. So that's what he's used to. And the reason why I bring this up is because we have a tendency to think that other people experience the things that we experience. So we classify problems based on problems that we've seen in the past. And this becomes difficult when faced with people who are used to different problems. Because people who are used to dealing with zebras, and you are a person who's dealing with horses, your approach to dealing with these things will be dramatically different. But it's not very obvious. Like one doctor who's used to normal people and one doctor is only used to 1 in a million diseases, they will have a totally different approach to how they deal with things. House will skip all of the normal tests because they've been done already. So what I'm going to talk about is something called the Cynefin framework. It's a Welsh word, so it has like a weird spelling. It's by a guy named Dave Snowden, not the Snowden, another guy. And he came from software development. He came from IBM, and but he's been working on this for a long time now. And it's what he calls a sense-making framework. Now, first I'm going to show you like his slide, and then we're going to go through it so I can explain it a little bit better. Okay, so this is how he draws it. So basically, he's splitting problems or things into different domains. So he has what he calls a complicated domain, a complex domain, chaotic, and obvious. It becomes a little bit abstract, and so we're not going to look much at this specific slide. So, but this is basically what it looks like. Now he has like these weird squiggly lines, and it's basically to show you that this is not a 2x2 matrix. So he makes all of these lines like weird on purpose to make sure that nobody draws it as a 2x2 matrix. But I'm going to use this to describe how people solve problems. So first, let's look at fixing things. If you have a problem in the chaotic domain, it's generally a crisis. So this is anything like, okay, let's say that somebody was shot in front of you. This is like, it's a crisis. And you are not a doctor, you're not in a hospital. You basically, okay, so what can I do to help the situation? Is basically the only thing you can do in a chaotic domain problem is to stabilize it. And that is enough, usually, to bring you out of the chaotic domain. So the moment you've stabilized the patient enough, then you come into the complex domain. Complex domain is where you have lots of these unknowns. You don't really know, and you have to investigate, you have to discover, you have to try things out. You're still kind of clueless on what is going on, but at least the situation is not like red alert anymore. And when you've discovered how things kind of work out, then you end up in the complicated domain. Complicated domain, you kind of know what's going on. Now you have to engineer a solution. And then moving from the complicated to the obvious domain, this is where you can automate it because it's obvious how this problem is solved. Of course, if you have a crisis in the automated domain or in the obvious domain, then poof, you're in chaos. And then you have to do it all over again. So, as he described it, in the chaotic domain, you have novel practices. You basically have to make something up. And this is like if there's a terror attack or some kind of accident, something's on fire in your house, you just have to make something up right then. In the complex domain, you kind of have to figure it out. And so they talk about emergent stuff, that you discover things. And the complicated domain, you're basically dealing with engineers, so they basically they have different solutions. Now they're trying to figure out which one is the best solution for this problem. And in the obvious domain, you basically have best practices. Yes, you should have source control. It's like that. It's not something we should engineer or make ourselves. Use something that exists already. There's sort of like very firm rules. One thing that you will notice that if you have some kind of leadership in the chaotic domain, they are usually very welcome dictators. They'll go like, we will do this thing. And everybody's kind of really happy that somebody took a stand and made a direction. And it's one of those times where being like this kind of dictator-y kind of things is something that people find very welcome because they want somebody to be leader in this crisis. But the moment you move out of the chaotic domain, being a dictator kind of sucks for everybody. Okay, so how does this map to DevOps? And this is kind of important because what you will realize is that a lot of these functions in DevOps, they operate in different domains. They're used to different kinds of problems. So in the complex domain, you don't know what you're going to do. You have to kind of figure it out. And so that's where you have your prototyping. You're trying to figure things out. You might make different tests and try different things, but you haven't really decided what is the best thing to do. It's a very fuzzy, weird place, and a lot of people are super uncomfortable in this area. It's more like art than science. Then you come into the complicated domain. You know what you're going to do. You just have to like decide. It's like, I could do it. We can have our deployment using Azure, or we can do it with AWS, or we can do it with this other thing. We're going to compare these solutions. Then we're going to figure out what fits the best for us. But basically, you know how this is. You know any one of them is going to work. You're basically trying to figure out which one is the best one for you. And then, of course, you might discover things while in the complicated domain where you figure out, oh my gosh, like none of these are going to work because we have this weird little requirement, which means that none of our obvious solutions will actually work. And then you go back to a complex domain. Okay, how can we solve this problem? And now it's unknown again, right? But if you look here, development, like software development, is there. Almost all software development is going back and forth between the complex and the complicated domain. This is an area where on the complex domain, you will make lots of stuff, but you will throw a lot of it away. In the complicated domain, you'll probably keep most of it because you decided what you're going to do. But this also means that you handle your code in different ways, whether or not you're in the complex or the complicated domain, which causes a lot of frictions in development teams. Because some people have a tendency to stay in the complex domain doing a lot of prototyping, and some people stay in the complicated domain doing a lot more engineering, and they will be pissed off at each other. Generally, the engineers think that the people in the complicated complex domain make a lot of crap that they have to clean up afterwards. So that there's a lot of friction there. Some developers can go back and forth. A lot of people can't. So they will generally be one out of the two. And so you will have a team where you will have like maybe one person that generally does complex domain stuff. And that will often be like the black sheep in the team because everybody else, he never makes any tests. Okay? And it's just, and his code is kind of crap and we always have to clean it up. But what is very, very interesting about the complex domain is this discovery, right? And of course, when you're done developing, then you're going to try to deploy. And this is something that is the same every time, hopefully. And so this is something you try to automate. Because there's no reason in having repetitive, easily, like fully understood processes that are not automated. It's like if it can be done by a machine, it should be done by a machine, then we don't have to think about it anymore. I messed this up once. I started at Opera. And I shared an office. Well, I shouldn't say that. I was asked to take over the build system for Linux for Opera while this guy was on vacation. And this was like I was barely into this, and the build for Linux as opposed to Mac and Windows involved lots of manual work. Basically, you had to log into a whole bunch of machines. I don't know, it's like 16 terminals, and then you had to start scripts everywhere. That kind of it was a very complex, complicated thing that basically took a full day to make one build. Which meant that the QA on Linux, they generally got a build once a week, whereas the QA on Windows and Mac, they got builds every day. But it was basically one person who was doing this, and that's how it was. And then this one person goes on vacation, and everybody goes, okay, so Patricia, now you can do it. Okay, I did it once. It was horrible. After doing it once, I spent 3 days writing the worst Perl you've ever seen in your entire life to like tape this thing together so I could push a button and never do it again. And guy comes back from vacation and he did not like me anymore. But that is what you should do. Don't do automated routine stuff. And like do so if it can be automated, automate it. So in the complex domain, you have this creative process. In the complicated domain is more of like skill-based. And then here you have automation. Of course, if you have some kind of error that occurs, and automation here, so it's like the generally production, right? So you have lots of things that is just running and you're hoping everything's fine. If you have a problem there, if it's not critical, it goes back to development. It's basically a bug, right? You just say, okay, there's something, the color here is wrong, or this is not intuitive, or when they press this really not important button, nothing happens. But if something really bad happens, like your site goes down or something horrible that you have to do right now, poof, you're in the chaotic domain, right? In the chaotic domain, you have to do something right now. Our site is down. None of our customers can do anything, something like that. That requires some kind of incident response. Now, people are on call. People are like working evenings. Now we have to do a thing. It becomes a big deal. So if we're looking at this like an incident in production, so you start off with this problem, crisis. You have to act. You have to do something decisive. And generally, in our business, that's restart the server or something. but something embarrassing like that. But it's basically you have to do something right now. You don't really know what happened, but you have to do something to get out of this, because this is a situation that is unacceptable. So somehow you have to get out. And then you move into the complex domain. So now you have to figure out what went wrong, because you really don't want this to happen again. But you still don't really know, but you're doing the investigation. And as you know what went wrong, you're moving over to the complicated domain. Okay, now we have to figure out how to solve it. And when you figure out how to solve it, then you also figure out how can we automate this so it never happens again. How can we add tests, some kind of monitoring in our system, some kind of bash script that runs at night that restarts all of our application servers, which is a bad sign. But the idea is and what is important to understand is that almost all of the things that we do in our life, it is moving between these categories. But many of us are used to working in certain categories more than others. And that influences how we think about problem solving. And so when you have someone who comes from operations and starts trying to work with someone who is in development used to working in the complex domain, these people have like a massive culture clash. You have one person who thinks that we should try all sorts of like unstable shit just to see what sticks. And then you have somebody who's going like, no, we have to make sure everything is correct all the time. Nobody should change anything. You have to go through the change management system. It has to be approved. There has to be a protocol. And these people are going to fight because they don't understand each other at all. And both of them think the other one is an a-hole. There's and until you realize that these things are going to happen, it's really, really hard to solve this problem. You might think like, okay, she comes in here, she's going to talk about DevOps. Why is she talking about this? It's because this is what explodes every time. Every time anybody tries DevOps, or even tries just DevOps, not with any security, this happens. You have lots of meetings where people fight and people talk badly about each other and nobody wants to work together and everybody thinks it's all crap. Okay, so if you're coming from a security background, to give like a mental model for this, you can say that if you're in the chaotic domain, a technique that you could use in the chaotic domain is fuzzing. So basically just throw stuff at things and see what happens. So it's basically very unstructured. But the moment you have an event, then you have to debug it. You have to figure out what happened. So the application crashed, but what happened? You debug it, and okay, so then you figure it out. Okay, so I can boil this down to this kind of exploit. So now you're in the skill kind of domain. You figured out what it was. Now you have to craft some kind of exploit for it. And then you can automate that by making a Metasploit, a module, for example. And so what you see is that this is nothing is in one category. Things have a tendency to move around. And what you will see is that the complex domain is mostly concerned with making the right system, what is right for our users. And oftentimes you think you know, but you don't really know. And so you have to try stuff out. And in the complicated domain, you're more interested in making the system right. There shouldn't be any errors. But then the thing is, you can make the system right, but it could still be something that your users find totally useless. And so you really need to do both. So in testing, you find different kinds of tests fall into different categories. So you have like Chaos Monkey, which is like from Chaos Engineering, which is a Netflix kind of thing, where they basically they automate making chaos, like turn stuff on and off, pull services out, see what happens, what breaks if we just do random failures in our network. This is because distributed systems are very complex. It's very difficult to model. And so you basically, it's sort of like fuzzing, but on like a system level, like on a distributed system level. But in the complex domain, you have things like A/B testing. Where it's like, yeah, we're going to make this and this, and then we're going to see what people think. Whereas in the complicated domain, you will do test-driven development. And this is also one of those conflicts that you'll see that people get really annoyed, that this person doing complex stuff never writes any tests. And the reason for that is in the complex domain, you throw stuff out all the time. Like you probably throw out 9 out of 10 things you do. It's absolutely usually a total waste of time on doing test-driven development in the complex domain. Because you're basically trying to figure out what's going to work. You don't know. Most likely you're going to throw it out. Whereas in the complicated domain, you're basically going to this, now we're going to make the system right. It has to do all these things, but you know what the requirements are. And then in the obvious domain, you have things like static analysis and plugins and stuff. Okay. So how does this fit in? In a simplified pre-DevOps deployment workflow, you did your coding, you did your building, you did your testing, and something, and then it's in production. And in between here, you have some kind of manual security gatekeeping. There's not only security, like many places, you had many things that could come in here. Like QA, for example, you basically only do your QA at the end, and then before it goes into production. But the problem is, when you start with DevOps, this is the critical path. And any kind of manual process in the middle of your critical path is unacceptable. So you can't do any manual security gatekeeping before you go into production. Because basically, push to production could be measured in minutes. There is no time for you to check anytime anybody pushes. So what are you going to do? How are you going to maintain security if things go straight out to production? So earlier today, Victoria talked about many of these things, so I'm not going to go that much into detail, but you can insert security in many of these steps, many of automated types of security in each step. So you have things like IDE plugins, static analysis, warnings, commit hooks, dynamic analysis, dependency checks, simulations, fuzzing, and then when you're finally in production, things like alerts and dashboards. Okay, but then you come like, okay, but I don't have a security team who's going to do all of these things. It's like, there might be a security person in my company, but I've never met that person. And it's like, yeah, this might work for other people, it won't work for me. And actually, you'll probably be surprised that it won't work for most people, right? And this is a slide that she also had, or like the number she already had. 1 security person per 10 ops people per 100 developers. And these developers are pushing constantly, right? Because now in DevOps, people are pushing to production many times a day, maybe. Each one of those 100 people. And you're 1 person. There's no way you can keep on top of this thing. It's not going to work. And it doesn't work. It didn't really work before either, but we pretended it did. Okay. So, what are you going to do now? So I'm going to give you 6 hacks on things you can do to modify existing stuff to improve your security posture. So first is live off the land. Basically, don't make up stuff. Try to hook up to whatever is there already. Try to repurpose things that already exist. So don't have your own issue tracker, use their issue tracker. So if the devs have an issue tracker, don't have a separate, different way to track your work. If they have all their stuff in Jira, you have all your stuff in Jira. Use their stuff. Use their Slack. Make sure that, like, let's say that you need a security channel where all of the security people talk about the security things. Okay, make sure that's in their Slack so that developers can come in and join. We'll talk about that a little bit more. Use their monitoring. So if they have monitoring or dashboards or anything, then integrate whatever you have with that. So if you have any specific security stuff you want to add to your network or to your production environment, try to make a little bit of glue code between that tool and their monitoring stuff to get your numbers into their dashboards, because you want to use their dashboards. And very oftentimes you will see like you might have some kind of intrusion detection system that detected an event, but what your devs will see is that, oh no, suddenly we have 50,000 more requests per second than we're used to. Because they also have their monitoring. Because what they're looking for is errors in production, whereas you're looking for specifically security stuff, but both of these inform on each other. Because if the devs say that, okay, we have an intrusion detection and our requests increase by this much, then those two things are connected. So integrate into all of their tools. Anything that they use, you make whatever you have inform into that. So that is an example, a simple example of that is like an IDE plugin, right? If you want them to use it, then find a plugin that fits into their IDE. Have the devs build it. Okay, you're one person, right? Maybe, part-time, possibly. So how are you going to do this? And basically what you have to pick your battles, you have to pick one thing at a time and then get it planned, because you have 100 devs per one security person. What you do have is a lot of people can build stuff. If you can get your tasks scheduled for their workflow, then they can build your integrations, they can build your tools, they can build this, they can do this glue code, and they can integrate it into all of their stuff. And that will also give them ownership to these things because they make them themselves. And one thing that you must see with something is like both, like when you're working in the browser is a little bit different than working in a web kind of thing, because you're shipping something to somebody's computer. But what you will see both in the old Opera that I worked on and also in Chromium is that the build system is in the same repository as the code. And now they've been slowly pulling it out to a separate repository, but it's managed by developers. They have their own dashboards for the builds. Their continuous integration pipeline is also in the same thing. All of the tooling around development and building and all of the build scripts are in the same repository. Everything is managed by the same people, because what the devs can do is build stuff. So you can use the devs to build the integration. And then you have to kind of find ways to justify it, right? Because one of the things that's really hard oftentimes is to get time to do security stuff, because your management thinks like, oh, who's going to hurt us? We're not very interesting. And so what you find is like dual purpose stuff, like you have them make something that will be useful for you, but that it will also be useful for shipping software faster, for example, or keeping higher quality. So that's one thing. It's like whenever you want to do something, see if you can sell it as a dual purpose thing. It's good for something else as well. And this one is quite interesting because it's quite controversial in many of enterprise kind of things. But studies after studies show that trunk-based development has a lot of advantages, and that is also something that they go through in this State of DevOps and in this book Accelerate. So trunk-based development, which is kind of weird because everybody's on Git, right? So trunk is from Subversion, but basically means everybody's pushing to master, and this is something that people don't like. A lot of people, especially if you used it to the complicated domain or the obvious domain, this hurts. Because you feel like, yeah, but I don't have control. Anybody can do whatever they want. This is like crazy. But what you will see is that, and that is also something you see with DevOps in general, is that people have a much stronger ownership when they push something all the way to production. There's nobody who's going to stop you. There's nobody who's going to gatekeep you. There's no one who's going to take care of it for you. Like I've spoken to developers and I would go, did you test this at all? And they go like, why should I test it? Well, that's what we have QA for. Okay, you got no QA, you're pushing to production, you have to take care of it. And it becomes a different way of thinking about your code, and it becomes a different way of working. But one of the things that you get from trunk-based development is that everybody has to push all the time. And that means you're not finished. You're making a feature, but you're working over several weeks. So you're not finished. You have to push all the time to production. How are you going to do that if you're making stuff that's not done? one of the good things about this, that if you have small commits, it's much easier to review. Like, nobody's actually going to review 10,000 file change. It's like, I worked on this 6 months. I have this joke that the size of a commit message is inversely correlated to the size of the diff. So if you have a diff that is like 20,000 files, you have a 1-line commit message. Added feature or something. But if you have like 1-line diff, somebody's writing a paragraph on telling you exactly why I had to change this 1 line. And the thing is, it's also absolutely impossible to review, right? So it becomes security theater to think that you can actually do any kind of security review, merging branches into master. It's not true. You might feel like you have control, but there is no real control. But if you do add security as an idea in your peer review tooling, you can add stuff, make extensions for it. This is what we have the devs for, right? Then you can add things like threat modeling your feature, or threat modeling this specific, have you considered things in your peer review process. But of course, since you're now pushing stuff and it's not finished, you have to have some kind of feature toggle. So now you have to be able to turn it off. And the good thing about this is something that you can also do when you have a crisis. You have some kind of a feature in production that is causing some kind of problem. If it is controlled by a feature toggle, you can turn it off in a config file. When it comes to stabilizing the situation, having a feature toggle and being able to turn it off is a way to stabilize the situation and go like, okay, well, we have to take it back to development because this didn't work. But you can sell this as dual purpose, right? Because feature toggles can be used for A/B testing. So if you now have feature toggles, you can go like, I'm going to turn off this feature for 10% of our users, but 90% will get the old feature, and now we can test it, and blah, blah, blah. And suddenly development and UX designers and everybody thinks feature toggles are awesome because now we can test it. You can turn it on for regions, like, oh, we'll have this feature only turned on for Europe. And this is probably the most important one if you're going to do something, is use the existing crisis process for incident response. Because one of the things is you don't really have a security team, and what happens if something goes wrong and you're just one person to 100 devs? This is hard. So first you just do the simple stuff. You have some way of security people contacting you. So you have the general one, have some kind of email address. And then, document it with security.txt. Have some way for people to contact you. Then connect this so that it will make an automatic issue in Jira. And give it some kind of priority. And have some alerts in a Slack channel when something like that happens. And poof, you have an automated process that when somebody sends something to you, it's immediately tracked. It's quite simple to set up. And now that part is taken care of. But the thing is, if you're coming from a security background, you think, okay, but I care about all these security incidents. Like, what if it's a breach, a data breach, all of our passwords are out? That doesn't happen that often. What happens a lot is bugs in production. Serious bugs in production happens a lot. People are used to handling serious issues in production. And very oftentimes you don't really know what caused the problem, but the symptoms are the same. We're having big issues in production. So I'm going to give an example of something that wasn't a security issue, but was a massive crisis. So this is a couple of years ago on GitLab.com. There was an accident. This is some guy who was just doing regular maintenance on a server. He was just cleaning up, he's doing some stuff, and then it's like, there was an rm-rf. And almost all of the repos, everything on GitLab.com was gone. Yeah, that was bad. And it got worse. Because one of the things that was interesting, I was paying attention at the time when it happened, because it was and one thing that was very interesting is that they talked all through the process. The moment it happened, I don't know how they found out, if their internal alerts went off, or if it was just the flood of people on Twitter saying what happened. But they talked throughout the entire day. So first off, they go like, okay, we've had an accident, we've deleted stuff, don't worry, we have backups. So we're going to try the first, like a layer one backup we're going to try first. And the backup failed. And then they go like, okay, this backup failed, but we have other backups. And I think they went to 3 or 4 different backups. And in the end, they managed to salvage it, right? But as they went through, they kept on talking about it publicly, which must have been horrible. Because you go in there like, okay, I'm going to fix it. And then it's like, okay, I failed. You have to say it to all of your users. It must have been an absolutely horrific experience. But one of the things that you know about GitLab.com after this incident, you know 2 things. And those 2 things are very important. First of all, you know they are going to test all of their backups. Always. This is never going to happen to them again, because this was really bad. This was horrible for everyone involved. I'm sure they spent months making sure that they had a backup process that worked and was testable. And the second thing is, you know they're not going to hide the stuff from you, because this was horrible. And they kept on talking about it in public. And this is the exact opposite of things like Equifax, right? Where people were trying to hide it for months while where your personal information was all over the internet. These people will tell you when they mess up. So what actually happened, which was kind of weird, is that a lot of people switched to GitLab.com after this incident. So something that was actually a huge crisis became actually a quality sign on how they handled it. But what you can see is that this is basically, it could have been a company killer. Like, this thing could just be the end of you. And it wasn't a security issue per se. It was an accident. It could happen. Nobody breached them, but it was the potential for this was massive. So does it really matter if it's an accident or a breach? So let's look at how you're going to find out. Let's say that you have a vulnerability coming in. What we like to think is that we get a vulnerability report. Somebody's going to send an email to that security@something.com, and then you're going to have it. It's going to be get into Jira, and then you have your priority, and then it's going to have an alert in your Slack channel, and it's like all of this like chat ops stuff set up, and you're like, hoo, we're really cool. But the thing is, it's probably going to show up as a bug report. Somebody go like, okay, I was trying to access my stuff, but instead I saw like James's stuff. Or I was trying to do this thing, but then I got a 404 afterwards. It's like you will get weird bug reports where people are mostly concerned with the thing that they wanted to do didn't work. But side information will be like something really bad happened, but they haven't interpreted this information. Another thing that will probably happen is it will come in on your social media accounts. Somebody will post a picture of their screen on Twitter and tweet at your social media people saying, what is this? Why can I see all of James' personal information? And the reason why this is important is that you have your vulnerability report channel. They'll probably go into your security related structure, people. This will probably be handled well. Your bug reports are going to go to QA or your support. And these people might not realize exactly what is the potential of this thing that has been reported. It's a big chance that you might never see it. And when it later explodes somewhere, then people go like, yeah, but I reported this to you 6 months ago and nothing happened. Even worse is probably social media, because it goes to marketing. This is horrible. And it is horrible in a good way. People who work in marketing, their job is to defend the brand. They are extremely defensive of the brand. This is generally a disaster for you, Because if somebody goes and says, okay, I can see all of your passwords. Like I could dump all of your database or something. They can, or I can change the URL and by that way access all of your customer data or something. And then your social media people start attacking them in public. This is horrible for your brand. But the social media people think it's good. Because it will make it seem like you have absolutely no control over security at all. Because nobody cares. All they're doing is trying to do like marketing stuff. But let's say that you manage to train your QA and your marketing people to not do anything when these things happen and consult you. You still go into a triage process. You have to figure out if there really is an issue. Maybe there isn't a bug. Maybe there is a bug. Maybe there's a vulnerability. But this is also the problem. Like if you look at people who are experienced in running bug bounty projects, this is the problem. That having a bug bounty for your product increases the flow, especially in the vulnerability and bug reports, a lot. And what people say, like, yeah, but we can do this. And I was like, how much money can it be that you're paying in bounties? And the thing is, the bounties, like the amount of money you pay in bounties, is you don't have to care about that. It's like no money. What it's going to cost you is handling all of the reports. You have to have suddenly 2 or 3 people that you have to hire just to handle the flow, to triage, to debug, to analyze all of these things, to set priorities, to figure out what is trash and what is real. And you have to do it fast. So as a rule, I would actually advise against having a bug bounty because this is too much and you probably can't handle it. But if you look at your organization as it is today, they know how to handle a crisis. They've had hard disk failure in production. They know how to deal with that. They have a process to deal with a crisis. And you can use that same process for security. And this is where you can add security features to their process and at the same time improve their process for other things. So you can add different kinds of priorities in the bug tracker to track what is some kind of chaos event. You can have a separate channel in Slack, and this is something that I've seen several places where they'll have a Slack channel and call it something like, I always do something really macho, like War Room or something. And in this channel is basically, you have a bunch of people who have alerts on their phones. If anybody talks on this channel, says anything at all, it's like phones start beeping in the middle of the night on lots of people's nightstands. But the idea is that if you see anything that looks like a crisis, you say something. And this is where everybody is, so everybody gets notified. And this same thing you can use for normal crises. And the thing is, if you use it for normal crises, people are used to handling it. It's something they do all the time. This time it was a security thing, but last time it was a router that failed. It doesn't matter. They are used to handling it. And then make an explicit side duty in every team, because you're still just like one person to 100 developers. But what you can do is deputize people in each team, right? Make one person in each team be a security engineer. Say that, okay, 20% of your time is being a security engineer. A lot of people want you to call them like security champions. Don't do that. Nobody likes to be called a security champion. It sounds like a cheerleader. It's like nobody's going to like that. Call them a security engineer. They'll like that. And then make some kind of simple procedure that happens, like what happens, and then like make a Google Doc or something, or a wiki page, and link it from the Slack channel, so that when something happens, because most likely the person who discovers an event is not going to be somebody who's used to doing it. So if you just have a simple checklist of, okay, this is what you do when bad things happen, then might be like, okay, create a new channel with the name, make a thing in Jira, call the person who is on call. You just make a little list of stuff that you should do so that anybody can follow the simple list when it happens. But this is also something that's very important. You have to have a real procedure on how people get paid. Because this is something that people in security are often very annoyed that developers are not on call. But the moment you now are integrating security into your development team, then you're basically, some of your developers are probably going to be on call in some way. So if someone like Jane discovers that her war room channel is beeping at 9 o'clock at night because some service went down in production, and she sits down at her computer and is going to fix it, how is she going to get paid? She's not on call. She's just a random person who picked up the phone and decided to do something out of the goodness of her heart in our off hours. You have to have a way that everybody knows how they're going to get paid. So you're going like, okay, so if you handle an incident at night, then you're going to get overtime. Just say it somewhere so everybody knows that you're going to get paid and it's going to be fixed. And then, as you heard earlier today, automate as much as possible. But because basically you're only one person, there's no time to do manual processes. And you use your developers to try to do this, right? So adding ED, all of these things that she said earlier. Oh, let's see. And the thing that is most important is that any kind of visualization has to be in the same visualization tools that they use normally. Because what you will see sometimes is that you will have some kind of room where they are monitoring production. Everything is green. And then you have like the security monitors and everything is red. It's like, oh, but we have a perimeter breach. Yeah, but everything's fine. Okay, that's not going to work. These things have to be together. You have to integrate your alerts into their system. Because if you are the only one watching these screens, then nobody else is going to care. And then you are going to be the one that's screaming and shouting all the time, and everybody's going to think you always make trouble. Nobody likes people who are always negative. So then we'll go like, yeah, it's a grumpy security person who's always angry. And of course, infrastructure as code. Now, this is something that you can easily sell to developers. Like, oh yeah, but then you can push it out and you can take down the pods and we can roll back really easily. But this is good for you. For security reasons, now you have configuration management. You have ways of saying, okay, this was the state of the production environment when we pushed this specific release, and you can connect these things together. And this makes it suddenly auditable, right? You know exactly the state of things. And that means you know what you're running, but it also enables safe rollback. So let's say that somebody pushed something that pushed out some kind of vulnerability. Now you can roll it back safely, because you just take down the pod, you roll back the infrastructure changes, and start up again. So basically, the idea here that goes through everything is try to use existing processes and what people are used to integrate security all over the place. Because this thing here, up here in the yellow box, that is where developers are used to working. That means they're used to working with a lot of uncertainty, where what they're measured on is if something is good for our users. They're measured on, is it good enough? Does it solve problems for our users? That is what they're going for. And this over here, that's your operations. It's like this has to be engineered and automated, and everything has to be well. And people who come from operations are usually really big fans of having procedures for stuff. Like, this is how we solve problems. These are the best practices. They don't like all of this touchy-feely stuff. It's like, it has to be proper. And then you have security folks, and they come down here. And they're mostly, it's like, I'm going to put in all of these sensors everywhere, so I know if something happens. And if it happens, then I'm a superhero, right? And so they are either in this sensing, protecting kind of state, where they're basically just feeling, trying to figure out if something bad is happening, and then also to like spring into action if something bad happens. But these types of roles are used to solving very different problems. And they very rarely understand each other. So very often you will find that operations and security people are like, oh, all right, because they both like structure and they both like automation. But operations people do not want a crisis. That is like something they do not want. That is like the worst thing. Security people kind of think a crisis is fun. Because it's like then you get to test all the things. It's like, and then you get to be the superhero, and it's like it's a little bit more like fun. For development, what you're mostly thinking about is the end user experience. So you're not really concerned that much about operations or security because that's not something you're measured on. So basically, I think this is a really bad drawing. I think this is probably worse. And this doesn't help. Because the thing is that all of these people do really valuable things, but they generally don't work well together. And so, how can you fix that? And that is basically most of the success of DevOps. And what you saw also from the Google's Project Aristotle. Google did a study where they tried to figure out what made our best performing teams brilliant. And what they thought was that what we'll see is a combination of like the people who are there, like the skills and what they know and how experienced they are and how good they are individually. But they didn't see a relation between the skills of the people and the performance of the team. What they saw was the teams that were the best performers, they trusted each other. The people in the team trusted each other. They felt what they call a psychological safety. They felt that if I speak up, nobody's going to make fun of me. If I say that I think this is a good idea, people will listen. If I propose something that's maybe unfinished in my mind, people will listen and think about it and they won't mock me. And that is so hard because we don't like to think about like all of that touchy-feely stuff. But that is usually where all of this goes to hell. It's that we don't trust each other. We don't trust that these people who do like this crazy stuff and make all of these like experiments and crap all over the place, that they are actually good, that they care about stability and keeping things secure. And what you end up as you go to security conferences where people constantly talk badly about developers, which annoys the hell out of me because you know what? The developers make the stuff that pays your salary. If you don't have developers, you don't have a product and nobody has a job. I had a QA guy who was really annoyed, and they are not even in the drawing, in a meeting where he said like, oh my God, everything's been so unstable and it's like, it's really annoying and the developers are really crap. And I go like, yes, you're welcome. And he was like, what are you talking about? You're welcome. And I'm like, yeah, but you know, if everything we made was perfect, you wouldn't have a job. And he goes like, okay, yeah, carry on. So the point here is what I'm trying to say is that if you go into this with your eyes wide open, that you're going to have issues. People are going to fight. But they're going to fight not because anybody's bad, but because they're used to different problems and they're used to solving them in different ways. Some people are used to looking for horses and some people are used to looking for zebras. And that doesn't make one worse than the other. Because House would be a horrible doctor to a normal person. Like if he was like a fastlege, he would constantly say, you have lupus. The thing is that people are used to one way of working. And those ways don't necessarily match. And so what you have to do is you have to trust that this person is also trying to do a good job. And that's sort of how you squeeze the sec into the DevOps. But what you often see is that people say shifting security left, and I don't like that either. I'm just going to say that right away because it also says like it's again these simplified views because you say like, okay, this is my pipeline, and then they draw these arrows that go back like this. You try to make pretty drawings, you try to simplify everything, but shifting security left where, right? Because if you saw the initial drawing, it was you had to put in security everywhere. Not only left, you have to put stuff in monitoring. You have to put things everywhere. There's no left. People like saying this thing, but it doesn't make sense. What you need is incremental security. You have to build it over time, layer it on. And that's you do by hacking what is already there. Add stuff. Put fast, stable, automated tests in the critical path. Put them into their continuous integration and continuous deployment pipeline. But they have to be fast and stable, because if you have like flaky tests, the devs are going to be angry and they're going to kick your tests out of the pipeline. So you put your fastest, most stable tests into the critical path. Use their existing crisis process to handle your incidents, because that is going to be a well-known process. People are used to it because they use it all the time. And then if you have slower tests, then take them off the critical path, because they're going to be annoying to people. Use their tooling and use their dashboards. Use everything they have to integrate your stuff into that. Don't come and it's like, oh, I bought this other vendor's system, which is only security, blah, blah, blah. Nobody's ever going to look at it. It's a total waste of time. If you can't integrate it into their tooling, it's a total waste of time. Don't buy it. And then you have to teach people what to look for. Because when marketing gets one of these screenshots on Twitter, they have to know not to answer. They have to know that they go in the war room and they go and ask, what should I do now? Before they answer. And the same thing for QA. The QA has to be like, okay, but if you see information leakage in any kind of bug report, if you see that somebody's talking about seeing stuff they shouldn't see, go to the war room and ask, what should I do now? Don't let it slide thinking it's not important. So we tend to classify problems based on what we're used to, and we have a problem understanding people are used to different kinds of problems. Some people are always looking for zebras, and that's fine. Thank you. Do you have any questions? No? Thank you. Some.